Just want to understand the concept. Okay, so here is a sodium nickel chloride battery. Okay, guys, when you look at the battery diagram, right, please don't get intimidated by it because there's 1,000,001 battery cells that they can give to you. Okay, all you need to ask yourself, right, is where is the oxidation and where is the reduction? That's it. Okay, from there you can work out everything else. Okay, the diagrams are always going to be a little bit different here and there. Okay, so there's two terminals, right, which I presume represents the two sides of the battery lah. Okay, then they say there's a big hint here that says electrolyte used is molten. Melting point is 157. Which of the following statement is incorrect? So they said nickel 2 is reduced to nickel. Nickel 2 reduced to nickel. The answer is actually B. Why is it B? Because very, I think it's very obvious, right? That they tell you the battery can be operated at room temperature. Room temperature is not 157. And if it's not 157, right, this ionic salt will not melt. And if it's a solid, right, it ain't gonna conduct any electricity. So it cannot be an electrolyte. So quite straightforwardly, option B is the wrong answer, which we are looking for, because they are looking for incorrect answer. Okay, so that said, right, we already know what's answer B, but we still need to figure out A, C, and D. Are they correct or wrong? Okay, so A, terminal E is the negative terminal, is absolutely true because it is the sodium electrode, right? Sodium electrode, sodium got oxidized. Okay, sodium got oxidized because they said nickel got reduced, nickel is reduced. So sodium side is oxidation side is negative polarity. You all still remember? Oxidation, negative. Reduction, positive for galvanic cell. Okay, so statement A, okay. Statement B, this has to do with little bit of your chem bonding, whether you all remember or not. You see the anion, right? Cl minus is much smaller than AlCl4, correct? So, and also remember the lattice energy for strength of ionic bonds is directly proportional Q plus times Q minus over R plus R minus. So if your R minus is like very big, is very huge. Wait, go away. If your R minus is very big like this guy here, then your lattice energy is going to be very small in magnitude, or at least lower than sodium chloride. Okay, so the melting point is going to be lower. That's why this option is correct. Okay, last one, very straightforward. The battery is explosive. If the seal is broken, water drips on the battery. Because remember, if water drips onto sodium, boom, right? Explosive. So this is correct.